Hello again. Are you still thinking about how a linear tool like lifecycle assessment can be used to better understand the environmental performance of a circular product? Good. Keep thinking along with me as we progress. Understanding how LCA can be applied to circular economy and circular products first requires an understanding of what is under the hood of an LCA, or in other words, the nuts and bolts. In this clip, we'll take a peek under the hood and look at unit processes. The key term here is unit processes. A unit process is a piece of data in the inventory stage. The inventory is actually built up out of a whole lot of these unit processes. In fact, all the processes at each stage of the product life cycle needed to deliver the other key word, the functional unit, must be included in the inventory. You can think about unit processes as the real building blocks of your LCA. Just to recap quickly, once you have the goal and scope of your LCA defined, including deciding upon a functional unit and your system boundaries, then you're ready to move on to the inventory analysis stage. Our inventory analysis stage is where we build up our product system. The inventory analysis stage involves first building your inventory with unit processes. As I said, try to think of unit processes as the bricks or building blocks of your model. After you've built the inventory, you're ready to perform the analysis. Before we go into exactly what a unit process looks like, let's have a quick look at how the inventory analysis step and the impact and assessment step fit together. Try to think about the lifecycle inventory as a long list of all the materials taken from the environment to make, maintain, and dispose of your product. Here we have crude oil extraction for the plastic we need in our disposable plastic coffee cup example. In other words, all the materials required for your product throughout its life, from cradle to grave. The lifecycle inventory is also a long list of the emissions released into the environment by your product throughout its life, such as CO2, reactive nitrogen, and toxic synthetic chemicals. In short, the inventory is a list of environmental exchanges throughout the life of a product. The complete life cycle, together with all the associated flows, including energy, can be referred to as a product system. Here we have another nice keyword, product system. So remember it. Once you have your inventory, you are then ready to translate that inventory into a description of what that means in terms of impacts that affect us human beings and the natural environment. All the resources used for our product and all the emissions created by the life of our product result in unwanted impacts, such as climate change and eutrophication. The impact assessment step tells us the extent of these unwanted impacts. Coming back to the building blocks analogy, unit processes are building blocks that account for all the material flows that are transformed. The transformation is documented by accounting for all the materials going into the unit process and all the materials coming out of the unit process. I'm using the word materials here to refer to substances, whether they are gases, liquids, or solids. So in other words, all the environmental exchanges caused by the product are documented in unit processes, including the use of energy. Don't forget energy. We document exactly what these exchanges are in terms of whether the flow of materials are coming into the process or whether they are leaving the process, whether the material flows are resources or emissions, whether they are from the natural environment or from other industrial processes, whether the flows are released into the atmosphere, released as waterborne substances, or released as solid materials. And of course, the exact chemical name of each flow and the quantity required by the process. All of these flows contribute to the product life cycle in some way. In LCA, we make a distinction between two parts of the environment, namely nature and the technosphere. Nature consists of the atmosphere, water bodies, natural land surface areas, and the subsurface. The technosphere is a general term referring to the man-made environment. The distinction is relevant to whether the material flows will end up in the biochemical cycles with unwanted consequences, or whether the materials will remain within the man-made environment for a certain amount of time before eventually ending up in the environment. So let's bring this back to our coffee cup example. Let's take out one unit process. Let's say the extrusion and thermoforming of plastic cups. This means the conversion of plastic granules to plastic sheets and then cutting and molding the cups from the plastic sheets. We have resource inputs going into the unit process, such as polypropylene, tetrafluoroethylene, and tap water. These three material flows are examples of inputs from the technosphere, since they all come from industrial processes. The unit process is part of the manufacturing phase of the product and downstream from processes that take materials directly from nature. If we looked at unit processes such as crude oil extraction, then we would see a flow of material from nature into the unit process. It is of course possible that in other unit processes in the manufacturing phase, materials are taken from nature. But for this specific unit process example, we only have materials from the technosphere. There are of course other inputs from the technosphere, such as the use and wear of machinery. The machinery is made of metals and requires maintenance. For now, we will keep the example simple and only consider these three inputs. On the other side of the unit process, we have outputs to the technosphere, such as waste plastic and waste water, and emissions of non-methane volatile organic compounds into the atmosphere. And of course, the process of transforming the inputs delivers us a molded plastic cup. Bear in mind that the processes in the life of a product can occur at different sites across the planet. The crude oil needed for the plastic cup might come from Nigeria, whereas the refining of the oil might take place in Rotterdam, here in the Netherlands. The manufacturing of the cup might take place in Germany and eventually be exported to another country where it will be used and disposed of. The different unit processes all occur at different times and are not simultaneous. The inventory brings all these processes that occur across the planet at different times together in the model. In fact, our model is made up of hundreds of these processes, which occur across the different stages of the product life cycle. Have a look at that. The inventory analysis allows us to see which processes are contributing most to the harmful emissions and which processes are consuming the most resources. In other words, the inventory shows us the extent of the environmental exchanges caused by our product throughout its life. The inventory can be presented as an aggregated list of all material flows. Before we get to the actual analysis of the inventory, there are a few things we need to know about LCA data and how to structure the data. Are you ready to take a closer look at LCA data? I know you are. See you next time.